Hi, I'm Dr. Alexander NGENZI from University of Rwanda College of Science and Technology, Department of Computer and Software Engineering. For what we have discussed now, we are going to see it as a block diagram and see what I have mentioned one by one. So consider the block diagram of DSP. Block diagram of DSP. So if you can remember very well, we have input side where we had, in this case, it's going to be analog filter. First of all, it's going to be analog filter, analog filter. In this case, of course, here we have input. We also have ADC, analog to digital. And this, I think we discussed this, but we want to bring the context of a filter system. So this is the digital filter, but in the whole context of DSP, digital signal processing. So we have also a DSP, digital processing. In this case, we have also this one. We also have another block diagram here, which is DS, digital analog converter, and then it's going to connect to analog filter again, and the exit analog filter again, filter. So you can see here it's connected, of course, this side, and having this side, for example, can be connected in this way. For example, it was to be extended in that way. So in the input for this where I say and rising filters from the beginning, which is going to filter out the highest frequencies, so that the unwanted signal can go into analog filtering system. So it is like connecting from input side, the input side. So it's going to be input and then be put into analog to digital converter. Remember, this is what I mentioned in my introduction, where I talked about the getting input signal, sampled input signal, and then it is passed through the digital processing or the digital processor to have all those sample signal into their main into the action. So for what we have discussed now, we are going to see it as a block diagram and see what I have mentioned one by one. So consider the block diagram of DSP. Block diagram of DSP. So if you can remember very well, we have input side where we had, in this case, is going to be analog filter. First of all, it's going to be going to be analog filter, analog or filter. In this case, of course, here we have input. We also have ADC, analog to digital. And this, I think we discussed this, but we want to bring the context of a filter system. So this is the digital filter, but in the whole context of DSP, digital signal processing. So we have also a DSP, digital processing. In this case, we have also this one. We also have another block diagram here, which is DS, digital analog converter, and then it's going to connect to analog filter. Again, in the exit, analog filter again, filter. So you can see here it's connected, of course, this side, and having this side, for example, can be connected in this way. For example, it was to be extended in that way. So in the input for this where I said rising filters from the beginning, which is going to filter out the highest frequencies, so that the unwanted signal can go into analog filtering system. So it is like connecting from input side, the input side. So it's going to be input and then be put into analog to digital converter. Remember, this is what I mentioned in my introduction, where I say I talked about the getting input signal, sampled input signal, and then it is passed through the digital processing or the digital processor to have all those sample signal into their main into the convenient signal that we want. And then from there, the digital processor, after getting the output, for example, say 1010 in terms of digital transform, then it can be converted again and in its output. But in the end, this portion will be having a reconstructing filters, realizing filter or connecting filter and realizing filter and reconstructing. So it has been joined or connected by using these filters from the input, but also reconstructing again because it has been separated through all these main block diagrams. Then it has to be reconstructing. So here it was, remember when I was explaining, I said it is, we can say you have a frequency. The input side may come with unwanted frequencies, and those are the highest frequencies, and we want to remove them. So after just joining them using these filters, it has to go in this type of analog filters. Remember, in most of the cases, the signal comes with analog format. It has to pass in the analog filters, and then it has to go into this conversion to get the corresponding digital equivalence using the DSP, and then you can just regenerate it again using construction. So each stage, for example, at the input, the signal will look, for example, like this. It will come, for example, like this. Then it will have some analog signal in this case, as we mentioned from our previous lectures. But when it is filtered, you may find, for example, at this stage, in this stage, for example, so from the beginning, this is what we are mentioning, and here also, this is the second stage, for example, you may have this one, and then be converted, for example, it will look like analog signal, but this one is somehow, the width is just increasing in this format, so in this case. So you may have this stage. So this is analog input, analog input. This is what we call filtered analog input. This is filtered analog input. If you reach there, you can start having digitized input. If you reach at ADC or analog to digital converter, so you will get the equivalent in terms of digital. For example, you may have like this, looking like this. So it will have some of the broken identified, digitized. It's going to be digitized input in this case. So we are here now. So before it goes to processor, it's going to be passing to DSP, the DSP or digital processor, and it will look in this way. For example, it will look this way, for example, but this one is going also to be very big, because it has put into processing unit and then sampled in this case, for example, and then it will look in that way. So all these are going to separate. So if it reaches the other side, it's going to repeat this system, and it goes all around, and then you will obtain in the end, after the structuring, you will get this signal and so on and so forth. So it's going to change according to what you are trying to get. So remember, when you are constructing or just taking from ADC, you are taking the signal to noise ratio, for example, at the N ratio system to minimize or to get samples outside from the system. Then you get the output again as analog. So this is a block diagram of DSP system. From this whole block diagram of the analog system, remember when we talk about the digital system, we are going to have three main components. First of all, we are going to have this one. So from here up to there. So we are going to have the ADC, which is going to be put in the digital system. Then again, DSC. As a system at large. So in general, if we want to explain DSP system, this is the general block diagram. But if you want to put it the digital filter system itself, you begin from here and then you end up from here. So there are three main block diagrams for digital filtering system. In summary, we have discussed about the digital filter system, whereby we discussed the main components. Number one, which is anti-aliasing component or filter, which is going to take the low pass filter that is going to avoid the high frequency and reduce them into the desired signals that we want. So in this case, the band is going to be reduced. The band limited is going to be reduced. Another one is going to be analog to digital converter, which is going to convert the analog signal. As you can recall in our previous discussions, we discussed about that, and it's going to take the analog into the digital format. And again, it has to pass into the processor. The processor may have the peripheral devices connecting to a DSC, which is digital analog converter, but the beauty of having the processor is it contains the memory and other peripheral devices that can help for the storage of the processed signal. So it has two purposes. Number one is going to be processing, and also to store the information for the future use. There's another block diagram also that we have mentioned is the DSC, which is a digital to analog converter that is going to convert the other digital format taken from our processor to their corresponding analog format. So in this case, it reaches to the point where we have to regenerate or restruct. We have to restruct the signal into their normal format. So in this case, we are going to have the reconstructing filters in the end to reconstruct our signal into their analog input, and then you can get the full package. So this was the main block diagram, and then we came up with the real diagram of digital format or digital system, whereby we said we have to remain with three components, that is ADC, DP, and DSC, or the analog to digital converter, digital processor, and also the digital analog converter. So in this case, we showed the diagrams, how we drew the diagrams. We drew different scenarios depending to which portion, and we showed how they vary according to the stage or the block they are in.